All right. So this is a continuation of the last lecture for part of it, and I'm also going to talk a little bit about some good coding practices because this semester we are doing more of a coding focus and we're using MATLAB. And the reason that we're using MATLAB is so that we can use Simulink at the end, which is more embedded systems focused. But along the way, as we learn MATLAB, I am going to kind of try and give you guys some good coding practices to just that you can know about them. And today, if we have time, you can also start on Lab 2 probably. All right, so in the continuation part, we have more built-in functions. And for these, I also posted a file that has kind of a lot of different helpful functions and what they do in MATLAB. So we have this function, which will clear the command window. And then a lot of the time for different functions, just like how in Unix, it has a man command that will tell you what what different functions are. You can also look up functions with the help in MATLAB. And we also have load from a mat file, and .mat is just a file that saves different variables from MATLAB. And you can save, so you can use these to kind of create breakpoints where you don't have to run this part of the code, and you can just skip that part by loading what that part would have done, given if it was a deterministic program, right? And you can also just clear specific items. You don't have to clear the entire workspace. And last time we went over all of these different operators. We went over defining different variables, how to create arrays, how to create matrices with arrays that have multiple rows. And we also went over how to concatenate them. And we also did a little bit of indexing, right? And this is all indexing, and these are the other functions that we started going over, right? How to create an empty array of zeros, array filled with ones, and we also talked about what is the identity matrix. And I showed you guys why it's called the identity matrix. And we also did the random function. And there's rand_i that will give you integers rather than a normal distribution. And they also have different characters, like just like your calculator, ANS is just the most recent answer. Pi is pi. And then it has imaginary units for the imaginary plane, if you are working with that. And it has not a number, infinity, and so forth. And then again, for those complex numbers, you have these imaginary units. You can get the real part, you can get the imaginary part, you can get the angle of those complex numbers. But for this class, we will not be using these complex numbers. This is something that you may use in signal processing, though. So in the future, you may use these, and you may use them with Simulink. And then going back into how it's MATLAB, right? So it's focused on math. It has lots of other functions like sine, tangent, cosine, right? You have exponents, absolute value, log with different bases. And also helpful is mod, the modulus operator. And over here, there's lots of different functions that will help with plotting. We're going to have 1, maybe 2 whole weeks on plotting in MATLAB. So you don't have to worry about these just yet, but this is a quick reference on how you can use plotting. And these are the different plot types that MATLAB supports. And you can also create these tables as well. Right. So going into programming, you've already made a function from before with the first lab where you printed out hello world. And here are some different structures for control. This shows you an example of if else, a switch, a for loop, and a while loop. So if you're ever confused about what's the syntax for a for loop in MATLAB, you can come here and you can look at it. Right? And this is uploaded to Canvas. So I recommend that you save this to your laptop or wherever you're using MATLAB to, just as a quick reference guide. And eventually you won't need it anymore. And these are also very helpful functions. You can get the length of your array, what's the size of all of the dimensions. You can sort things, and this function can take in more parameters. You can sort it numerically, alphabetically, things like that. And you can also flip, reshape. There's a whole bunch of useful functions that operate on matrices here. So this is all of the built-in functions. It's basically a kind of 4-page documents, quick reference guide. If you're trying to do something, maybe it is already built in and you can just look it up here. And if you can't find it here, you have Google, you have ChatGPT, right? Lots of places where you can ask about different functions in that. Any questions on it? Do we want to see any of these functions working? All right. In that case, we can move on to test-driven development. So this is the coding practice that I want to go over for today. Again, I'll sprinkle these in whenever I feel that there's a good opportunity for it. But has anyone heard of test-driven development yet? What do you think test-driven development is?
Keep testing whatever you develop as you go.
Yes, that is one of the core tenets. But what do you think the very first step is? And what you should be doing when you're coding?
Have an idea where
Yes.
structure.
How are you going to define what that is? Yeah, I mean, you can do all of these things, but in test-driven development, the way that you define what your function should do is the first step is to write tests. You have some input. You know what the expected output is. Compare that to what the function is actually outputting. And if you have a sufficient number of tests of covering different types of inputs, now you have a well-defined structure of this is exactly what the function is supposed to do. Rather than just a short, maybe, description at the top of the function with a comment header, right? So in test-driven development, you actually write the test first. What do we think the next step is? It's actually not write the functions. Nope. How do we make sure that our test is working? There's nothing to debug yet. We are going to run the test. And when we run the test, we don't have any implementation. What should the test do? It should fail, right? Because we haven't implemented anything. So if my test passes, then I need to rewrite my test, right? So if they pass, I need to go back to writing my test. If my test fails though, then what is my next step? Yes, write the function. And this is if it fails. And after I write my function, I have my first draft. What should I do? Run the test again. And here, let's actually make another one because we don't want it to go back to write test if we pass. So we're always going to go here. Then here we're going to run tests again. And if we pass, are we all good? Maybe. But maybe you might want to write more tests if you pass. You might want to write more tests. So we'll say maybe. And if you fail, go back to writing the function again. So that's why this is test driven. You're going to write the test first. Make sure that they fail because you haven't implemented anything. Because if they're passing and you haven't implemented anything, then your function doesn't do anything, right? Or that means your tests don't matter. Then you're going to write your function, test it. If my test fails, then I go back to my function, debug a little, try and figure out why that test is failing, and do this circular cycle. That make sense?
Just pass on the first try.
So like if you maybe write a test that is testing the empty case and it just is supposed to return nothing. Right. Or if you just have a bug, right? When you're writing the test, because you are manually writing the tests as well. So you just want to make sure that your tests are failing with no implementation. So does this make sense? So this is used still widely in industry. You'll have some roles that are just solely dedicated to writing tests and running those tests. And it's also good practice because then you can ensure that you are not going to break everything when you push to main branch. So the next question is, what should those tests look like? Like, what should we be testing? What's the simplest test for input if you are accepting inputs, right? Well, just think about the inputs first. Because basically our tests are just going to differentiate based on what you're inputting into it. Like if I made a function for addition, maybe something that would be obvious to test is like 1 + 1, 1 + 2. But what about certain edge cases? Right, like what you might consider 0 to be an edge case. And making sure that 1 + 0 still returns 1. Or maybe having an input being negative is an edge case. Or maybe your user inputs a character instead of a number. That's also an edge case. And you would want to make sure that your function would return some error statement to the user telling them that's an invalid input. So we want coverage of multiple cases. And I guess this slide is called what to test, but we can talk about tests in general. Is there anything else you want to add to what to test, though? Or is this coverage make sense to you guys? You're just testing the entirety of the function, right? So like example 1 + 1, 1 + 0, 1 + -10, like you're testing these different combinations. You obviously are not going to test everything, right? What about a + 1, things like this. We want to make sure that our function covers all of these different possible types of inputs from any kind of user, and our tests are going to reflect that. So anything else that's you think would be important when writing or running tests? Have you guys written any tests so far in your programming classes? Mhm. You really haven't done any tests?
Not that I can think of.
You've taken 311, yeah?
Yeah.
So let me ask you this. How often do you think you are going to be running these tests? A lot. Every single time you touch your code, right? So do I want to make the process of running those tests and seeing the results fast or slow? Yes. So we want to kind of make the results obvious. Just have it built in at the end of the testing script. All tests pass. This test, this test, this test failed. You don't want to have to manually check that my test is going to print out the expected outputs and it's going to print out my functions output, and then I have to actually check that they match. You want to make sure that your test will do that checking for you and output if it's going to be a fail or not. And ideally, you just have one printout at the very end. It's just all tests pass or 3 tests fail. Here they are. So then you can go back and look and debug for exactly those tests that are failed. And along those lines, you want to make sure tests are fast. You don't want to write a test that is going to take 30 minutes to run. Because like we talked about, every single time you touch your code, make changes, you should then test to make sure that you did not break anything that was previously already working. And if you have a test that runs for 30 minutes, it's going to hinder you quite a lot. Anything else that we want to add to this list? When should we write tests? Yeah, like, well, I mean, should I write tests for the final program only? Or should I be? Yes. So we want tests at all levels. Right? So I think this is good for guidelines on writing tests. And just, I know that you haven't done testing, I guess, but it is good practice. And I don't know of anyone working in industry that is not dealing with writing tests. It may seem like a tedious task that you don't need to do, but it is very helpful for very large projects. So it might feel kind of tedious with the small programming projects that we have, but it's a good skill to build on for the future. All right. So that's all I had for today. The Lab 2 document is posted, and you can use the rest of today. You have 20 minutes. I think it's possible to finish. So I will give you the rest of the time to work on this.
Oh, no.